morning to everyone. My name is Francesco Fedi, and together with Lieutenant Alessandro Cignoni, we will speak to you about a new methodology based on hybrid world to validate performance evaluation of multi-robot cooperative systems. Just to have a very little introduction, emerging systems are adopting more and more unmanned autonomous vehicles as key components. And the multi-robot systems is indeed a step forward of a single autonomous vehicles. They are characterized by cooperation among unmanned vehicles, smart sensors, and humans inside the operation scenarios. So there are many engineering problems to be solved, because if we want to validate the cooperation capabilities of such systems, we need to recreate somehow the scenario where they will are going to operate. And this is not easy based only on physical nodes, because if we think about 10, 20 or more unmanned autonomous systems which are cooperating in a very large area, it's not feasible to do that only based on physical nodes. So we have moved to virtual nodes, and to take always in the loop a physical node, just to take account on some effect that a physical scenario can have of this a single node where it is in operation. So we have decided to have a system which can allow maintaining trust scenario, maintaining the current software actually deployed on each vehicle, to have a scenario which can have many nodes moving together, cooperate to fulfill the same mission. We start with the adoption of a standard, which is specified by Orbit Management Group. Real-time data distribution services are a real-time middleware which has been specified to address highly connected real-time network system. The standard is very useful when we have large systems composed by heterogeneous nodes, and we need to interoperate in real time among these nodes. Adopting this standard, we cope with virtual and physical nodes without modifying the target software hosted by each node. Sistemi Software Integrati developed an implementation of these standards, which also includes specific mechanism functions for highly mobile environment systems. Specifically, we have a full support for mobile ad hoc network, so we interact directly with routing protocol which characterize this kind of networks. We also support specifically constrained, bandwidth constrained typically, which are typical of disadvantageous networks, so we cope with very low and intermittent bandwidth, and also the information assurance among the different, the data exchange among different nodes are protected by internal mechanisms of these standards. We have a large kind of platform to be supported just to have different kind of node. We move from host to mobile node with real-time operating system, to embedded equipment like National Instrument, LabVIEW, and so on, and also tablet with Android. All of these nodes are linked together, can exchange together data via our BEE DDS. Upon the middle real time, we designed a cooperation services, which are typically the set of services which adopt cooperating robots. So we have a cooperating service among unmanned vehicles and sensors to perform a given missions. And our need is indeed to validate and evaluate the performance of many tens of unmanned vehicles cooperating to perform a given mission. And this is our first engineering problem we have to solve. A first step of our test bench for validating and evaluating performance of such systems is the adoption of robotic operating system. This is an environment which allows to be platform independent. You can develop your robotic capability without taking account about specific of robotic platform. So we can move your software component among physical and virtual platform without any change at all. It's very important for the kind of system we develop. Moreover, we build a connector with the 3D engine in order to have a 3D scenarios with a same distributed architecture of our software. So we can have different nodes with 3D engine, nodes with virtual robots, and nodes with physical robots together in order to obtain a validation test bench or simulation test bench know-how, which includes cooperating together, operator console, physical robots, virtual robots, and the engine, 3D engine, which acts as a unique presentation tools, where the operator can also interact to create events in the 3D world, which can change the condition where physical and virtual robots are operating. Now I'll leave the room to Lieutenant Cignoni.
Okay, thank you very much, Francesco. And before going the speech, I'd like just to spend just a few words to remember a memory of a friend. He was a great sailor and a master that is no more with us, just leave. And so I'd like to go now to the speech. And I'd like to focus NATO Modeling Simulation Center of Excellence project and why we decided to go deep in this activity with two industries. The first point is DDS. DDS, which is data distribution services that Francesco well explained to you all, is a very important technology for real-time distributed simulation. For real-time exchange in real systems, and we consider the M&S CoE as a possible important technology for a future standardization, perhaps, in real-time distributed simulation. So we want to look more in detail to this kind of technology. The second point is related to modeling and simulation of complex systems in the operational environment. Unmanned elements are reaching more and more autonomous capability. First of all, for safety. We all know that if we have a UAV flying and the electromagnetic field is not at home, and also home we have some interference between Wi-Fi, TV, and so on. In the battlefield we may lose contact, radio contact with the UAV, and for safety reasons there are some autonomous function in any UAV, for sure. But perhaps if we have more function, more autonomous function, we may have more intelligence, more effectiveness in the mission, but this is going to be a complex systems in our scenario, which is not manned. And that's the second point. The last point is what we decided to call hybrid words for multi-robot simulation. This is speaking in a language, in a standard language, I would say this is constructive simulation with system in the loops, hardware in the loops. But we do prefer to use this term, sorry for that, but hybrid means that there's reality, virtuality, and you don't understand what is reality, what is the virtual world. elements, intelligent elements, act in the same way in the real or in the virtual world, and this is this kind of hybrid world I'm talking about. I stress about DDS. There is a paper from Josh and Castellotto. The paper is a comparison and mapping of data distribution service and high-level architecture. I take their table, their work, I put here, and in the table there's a comparison between HLA and DDS. There are some similarities between DDS and HLA. DDS is a service-oriented architecture protocol, so it has a publish subscribe mechanism, and it supports object modeling and the notion for sure of disseminated updates, but it has no support for time synchronization, which is in HLA, or the management, the DDM, it's not support specifically. But there are some differences that again is the one important I want to stress here is the focus on the quality of services support, which is in DDS, it's also going is also in HLA evolved. So there's this kind of more use in real system, and so more focus on QoS support in DDS. Now I want to explain the second point in this scenario, which is the evolution of unmanned systems in autonomous systems in the battlefield. So more and more we have autonomous system in the C4I star battle network, and more we have elements that have to interact, and I use the word complex. To define complex system is complicated, it's not easy at all. There are a lot of different definitions of complex systems. Perhaps the one I prefer is that, you know, electromagnetism, and so the Maxwell equation are two equations, and to describe a lot of very difficult interaction in nature. This is not complex. This is something difficult but not complex. A complex system is something that we can't describe with two words. We need a lot of words to identify what is a complex. That's my personal definition that I do prefer, but there are really a lot of definitions. But something is happening or will happen in the battlefield if you are putting intelligence to robots. And there are simple components, not simple at all, but components or agents, simple relative to the whole scenario. And there are no linear interactions among components, no central control, because I said before, sometimes you can lose the link, but the system has to survive in the battlefield, has to accomplish the mission, and so there's a lack of central control for sure. And there are some emergent behavior, and we have to understand what are those emergent behavior, because we don't want to put things on the battlefield and the scenario is changing and the behavior we do not expect is emerging, and something we do not want the robots are doing there. And the other thing where modeling and simulation can be a sort of linchpin to go deep in the understanding of this, and that's why we are interested in it, is in the algorithm of self-organizations. So I use some word like foraging. Now perhaps they're foraging the robots. It means that there is, we have to look at biology. They're looking at biology, scientists. We have to consider battery, energy. We can't consider an element in the battlefield without considering all the, let's say, an holistic approach to the problem, everything to the problem. So this is one of the biggest challenge, the energy, what I call foraging. And synchronization, like flocking and task allocation, and going to a swarm. But our was a first step, so I talk of complex things, but we have to be able to do simple things. If you are not able to do a simple thing, please do not talk about complex things, please. Sometimes we do talk about complex things without being able to do. So, we decided to use real systems, so to face with hardware, iron, which is used in the battlefield, and we use a UGV, giving some autonomous functionalities, putting inside the DDS, the SSI DDS, and using that in the real world. The UGV is actually used in Afghanistan, so it is a real equipment, it's not a laboratory run. Then we use a real communication systems. We test cooperative algorithms, and last we envision a training interface, but it's a training interface perhaps not only for man, but also for machine learning capable systems that are put in the battlefield. So, last I'd like to thank the Italian Army and Squadra Trasmissione dell'Esercito for the support to the experimental activity, anti-SIP simulation for the 3D creation, and the two company which are Eurolink System and SSI, because Eurolink gives the robots, SSI the communication frameworks. If there's time, I have a 3-minute video to let you show, if I found the mouse, that's complicated too, to show you our activity, our experimentation. question if there's time.